talk, how is GNU Linux? And in this talk, I'm going to be describing how GNU Linux works at a rough level. So let's get into it. First, this talk covers a lot of content, so I think it's good to get a rough roadmap of what's going to be discussed. So first is a brief introduction of all of the major steps from going from pushing the power button to having your graphics running. So that's first, and then we're going to be going in deep detail of each of the components individually, and then some key points that aren't really related to that, but important for Linux to run. And then finally wrapping up with some screenshots. So yeah, to begin, there's kind of what I consider the general initialization, stuff that you just have to do in order to use the system at all. So that starts with the boot firmware, which in my case is a Libre boot, and that is on a ROM on the motherboard, and that is how the system knows how to initialize when you first turn the computer on. And then that loads control to the bootloader, which in my case is grub. And then from there, grub does some basic initialization, mostly loading the kernel, and then it passes on control to the kernel, which does even more initialization, setting up memory, virtual memory, setting up virtual file systems, doing all that fun stuff. And lastly, the kernel opens the first program in user space, which is going to be your init system. And in my case, that is system D. And then after that, you're kind of ready to start hacking away on your system in user space. Technically, the system, or init system, is also in user space, but I put it in the other slide because you kind of just need that preemptively anyway. And so that, first there's your shell. That's what interprets your commands when you type them. You need that because it's pretty hard to do stuff with that shell. And then the windowing system is, of course, optional. Probably you're going to want graphics unless you're a turbo nerd and use Emacs. And the window manager works in tied with the windowing system. They're two separate programs, but we'll get into the intricacies there. Just remember that they are two different programs. All right, so the boot firmware. Typically, this is proprietary. It's your BIOS. Again, it's on the chip motherboard. And in my case, I don't like proprietary software, so I replaced it with Libre boot. We'll get into the details of that. But what this does is very basic hardware initialization. So for powering on your CPU for a reset, initializing the North bridge and the South bridge, which is I'm probably not qualified to get into details on that, but stuff like I/O, and also setting up the memory. So that's what that does. And this is also where you choose the disk to continue booting from, because if you have multiple disks on your system, you don't know which one you're going to boot from. So that's why you have to choose. So here's a screenshot just of what I did over the summer with Spice. Right here is the boot firmware on the chip right there. It's a WSON 8 chip. And this is basically how you turn it from proprietary into Libre. You have to write it with an external CPU because Lenovo is mean, and they make it so that internal CPU doesn't have to read such write permissions to that chip. So that's what these wires are doing. You're basically just getting around that limitation. Once you have Libre boot flashed, you are able to write to it with the CPU over here. So that's cool. But you need to Libre boot it before you can do that. And the bootloader. So once your ROM is loaded, it passes on control to the bootloader, and typically this is going to be I don't know how UEFI works, but with MBR, it's the first 512 bytes on the first sector of the disk is the initial where it's stored in memory, and then it goes to where the rest of the program is stored in memory. It's not really important, but that's how it does it basically, is it just starts reading the data from the first disk. And what that does mostly is it's to choose what kernel you want to use / operating system, because you can have multiple operating systems on one disk with multiple partitions, and you need a way to choose between them. As well as the kernel, you can use older kernels, but typically, you just choose I want to load in Parabola or Gen 2 or whatever. And another thing it does is it loads the initial RAM file system. That's what init RAM FS means, into memory. This is necessary because you need a file system that you can use, that the kernel can use to do its early initialization and to load the real file system. So that loads it into memory as well as the kernel, and then passes on control to the kernel, which does basic operating system setup, stuff like setting up a virtual memory system, the virtual file systems, because you can have multiple different like ext4, I don't know what the other ones are, of disk partitioning schemes, but the kernel needs a way to communicate to all of them. So that's what the virtual file system does, and it actually physically mounts the initial file system, or the init RAM file system. The bootloader loads it into memory, and then the kernel actually mounts it. And using that initial file system, it's able to mount your primary file system, and then it will unmount the initial one and just turn that into RAM. And once all that basic setup is done, the first program that will be created in user space is your init system. And then here's a couple screenshots that I just found in my system. The first one is some data from the kernel itself. That's stored in /boot / the kernel name. In my case, I'm using Linux Libre, the Libre version of the Linux kernel, and that's just miscellaneous data. How the kernel knows what init system to use is the symlink right here from sbin. And what a symlink is basically just a shortcut in Linux terminology. So that's how it reads that, and it's like systemd, or maybe it's a different init system on a different distribution. And this right here is top, which is a program to run that shows all of your processes. And if you see here, process ID 1 is going to be the first process that's ran when you start your system, or when the kernel spawns the first process. And if you see, the command is systemd. So the first process ID is always going to be your init system, just because that's how Linux works. So the init system, typically it's going to be systemd. There are alternatives, OpenRC, I know. Let's get a more old school one, run it in S6. The difference is systemd is more, it's not just an init system, it does a lot more stuff. It's convenient to use. And that's why most distros opt for it nowadays. But if you're someone who doesn't like one program doing everything, you might opt to use something like Runit or OpenRC, and they're just more simple versions of the same thing, basically. And one big job of the init system is spawning your daemons. The daemon is just a background process. So some of the big ones is Network Manager. This handles wireless networking. Another thing the kernel does, I forgot to mention this, the kernel sets up drivers, so your networking driver, your sound driver, stuff like that. And the network manager handles wireless networking. You can also use WPA supplicant, which is more old school, lower level one. Usually you only use that when network manager breaks and you need to fix something. It also spawns your TTYs. So these are basically the virtual consoles that you interface your system with. And it's really important that these get spawned, because otherwise you can't log into the system unless you have a different, maybe you have a TTY7 that goes straight to X. But in my case, I don't. So I need those TTYs. And blues is just for Bluetooth. Another example. Some other daemons, I think it's NTCPD, something like that. That's to sync your time. And that's kind of what the network, or the init system does. It also mounts the rest of the file system if necessary. Some people like to split their partitions to a separate /home partition. And if you're updating your kernel, you will need to mount it to update the kernel. So it handles doing stuff like that. It also checks the validity of the partitions on the first boot. just as a quick thing. And again, I have this question here. If anyone knows, what happens if you disable all of the TTY daemons and try and boot your computer on? Does anyone, any guesses?
Does it break?
It does break, yes. It makes it so you can't log in. So don't do that. That would require you to SSH in or boot off of a USB and do that. That's another daemon. SSH is important. Your init system handles spawning that. SSH, if you're not familiar, is like a remote connection thing. Okay, so the shell, this is important to mention, I think. It's kind of not related to the other things, but it's basically what interprets the commands you type into your console, and it executes the command. Typically it's bash, which stands for bourne again shell. I use ZSH just because I like ZSH, but bash is definitely going to be the most common one. And the easy way to tell is if you do echo $shell, that will print your environment variable that tells you the shell you're using. So yeah, that's just what shell does. And here's just a screenshot of actually signing into the TTY. So when you first boot your computer on, this is the very first input that you're going to be doing onto your system. Typing in your password and your username, and then it prints the message of the day, which is just reading it from a file. You can change it to wherever you want, but I'm using Parabola, so that's what they put for it. And then this right here was just me taking a screenshot of this, because it's kind of hard to take a screenshot of the console. That program does it though, which is cool. It's called frame buffer grab. It grabs the frame buffer, and turns it into a PNG. Alright, so finally, you've loaded your kernel, you're in user space, you're logged into your TTY, you're finally able to start typing commands. And typically, the first command you're going to want to type is start X. What this does is it starts the X window system. An alternative to it is Wayland. Wayland is newer and a lot better, but X is still pretty popular, more stable right now. But it's also really old and weird and hard to use if you're a developer. I'll get into that, but the key of it is that it's a client-server protocol, which the reason for that is historically in the 90s, X was designed so the server is running the X server in a different room, and then you have the clients which are speaking to it. Like say you might have a bunch of clients and then one server for a company or something like that. And that makes it really weird when you're using a laptop, because your laptop is your server and your client, but it still has to use a server client protocol. And that's the big advantage of Wayland, is it modernizes this and streamlines the process for use with the intention of not being a client server. And the big thing it does is it handles events. So like when you type on your keyboard, when you're on X, or you move your mouse around, the X server sends events to whatever program you're in, and that's how that happens. I'll get into that in more detail. And it bullies the window manager around, telling him what to do. And I'll introduce that later. Here is a picture that I took from the XLib Programmer's Manual. It's a pretty nice diagram. And the important part here is the X server communicates to XLib, which is the library that handles requests and receiving packets. And the X server is the thing that physically draws the graphics on your machine. So that's why it's on like the monitor side, and then it speaks to the client application. And in X terminology, a client is any program that's being ran. So like your terminal, the window manager itself, any program is a client. So the client is not like the client of the computer, which is why it's kind of confusing. And so how it works is X server sends events to XLib. So when you type your keyboard or whatever, it generates events, sends those to the client application, depending on what it is. Maybe it's your terminal and then it's to the terminal, or maybe it's your window manager, in which case maybe it kills the window or whatever. It also goes the other way, where the clients can send requests to the X server, and that's how like drawing and resizing happens. When you resize a window, that sends events to the X server from the window manager saying, hey, update this so it's bigger or smaller. And the window manager, again, it's a client is what they're called in X terminology. It's just a program, and it draws taskbars around windows. It handles resizing, the taskbar is like the thing on the bottom of the screen. It handles resizing and the physical appearance of the graphics environment. The design philosophy of X is that the X should be completely agnostic to what the system looks and feels like. The window manager is what handles the feel of the system. And this is also a really nice picture from the XLib Programmer's Manual to get into how it works a little bit. You would need to introduce terminology called a window. So they're called a window manager. What are windows and what are they managing? In X, a window is everything that you see. So this right here is a window. This is a window. This taskbar is a window. The scroll bar is a window. This is a window. That's how programs work. Is there like windows on windows on windows. So the window manager creates. This is the window frame. It creates that and it reparents the original client window. So when Xterm spawns, it's just this window, and the window manager takes control and reparents the window manager to become the parent of it. So now window manager owns this root window, this big window, and it draws a frame around it. But it doesn't own any windows further inside. That's still controlled by whatever client. So that's how that works. And the reason it's able to do this is because technically any client can move, kill, do anything to any other client. But the window manager has special permissions to where it's actually able to do that. And you just don't let it go deeper than the very top level window of each application. So I think this is a good time to talk about what a desktop environment is. So I think this is a topic that's easily confused when you're new to Linux. And the desktop environment is different to the window manager. A desktop environment is just a collection of packages. Most obviously is going to be the window manager. So say you're using like KDE, GNOME, I don't know what are other desktop environments, Cinnamon. You might have the GNOME window manager. You'll also have like the GNOME terminal, the GNOME file system, and all that together is the desktop environment. And any distro can use any desktop environment. Distros are not specific to desktop environments. I think most people choose distros based on the desktop environment they come with. It's important to remember that it's just software. You can install it on any distro you want. And another thing is the package manager. So the package manager installs packages. It handles updating, deleting, installing packages, updating your system, updating your kernel. Very important, you need this. And distro-based distributions use apt, Debian distributions use apt. Arch-based distributions use pacman. Void uses XBPS. Gentoo uses portage. That's not really that important. They all do the same thing, just with different design philosophies. But you need it because you need some way to install packages, unless you're a turbo nerd. You need to do it like that. Right. So finally, what is a distro? A distro is just a collection of software choices and design decisions. Stuff like the message of the day, and the TCY spawn, what package manager you're using, what bootloader you're using, not really the kernel. They're obviously using different variants of the Linux kernel, and stuff like that. So that's what a distro is like different versions of software. And the big one is the package manager. That's like mostly, in my opinion, what you choose a distro on is like the package manager you like, as well as just like how easy it is to install. And again, that's just like a list of the things that might change on different distributions. The kernel is like, in my case, I'm using Parabola Linux, which is a fork Arch Linux that's specifically only free. So it uses the Linux Libre kernel instead of just the basic Linux kernel. I think the only difference is a Linux kernel bakes in some proprietary networking drivers, stuff like that. The init system, run it, OpenRC, S6, systemd, package manager, and the window manager, or maybe some distributions, like I think Fedora uses Wayland, but most still use X. And then superficial configuration like the daemons that are automatically configured to turn on, the message of the day, you know, stuff like that. And another point is audio. Audio in Linux works with a layered system, unless you're using Pipewire. Does Pipewire also use Pulsa? Does anyone know? Alright, I'm just going to ignore Pipewire for now because nobody really uses it for the time being. Pulsa is a thing that interfaces with the kernel at the hardware level. That's what communicates with your sound drivers. You need Pulsa to do anything. And Pulse Audio is a layer that's built on top of Pulsa, which has more modern features like individual application sound control. Pulsa doesn't support having like Spotify at a different volume. They're all the same volume in Pulsa. And I think there's just like more calls, like YouTube and stuff like that. Games usually require Pulse Audio to run properly. And finally, this is kind of just like a walkthrough of booting my system. And first is a firmware, which again is LibreBoot. Up there, you probably can't read that, but I selected the first thing, load the operating system. And I only have one disk, so we'll just go straight into it. The bootloader, which in my case is Grub. LibreBoot is a little different than most distributions. Typically, the bootloader is on your disk in the /boot partition, but in LibreBoot, it's baked into the ROM. So that's why it still says LibreBoot up there. It's not Grub, but it is running a Grub program. It's just technically, in my case, I'm still in boot firmware. From there, I chose Parabola. If you want to choose a different kernel, you would go down to the next option and choose like maybe an older version of the kernel. Like if you're booting breaks for some reason, it's a good idea to try a different kernel. And then the kernel starts loading. Actually, technically, right now, it's still the bootloader. When it says loading initial, or loading Linux Libre LPS and loading initial RAM disk, that's loading the kernel and the initial RAM file system into RAM. And then it passes on control to the kernel, which starts systemd, and then that's just saying dev/sda2 is clean. That's saying that my primary partition is clean and systemd is started. And then finally, I go to my shell and I type in, password and username. This is a daemon, again, that's spawned by my init system. And then there you go. And I type start x, and that starts my X server. And then from there, you have, woo, graphics. So that's the process, basically. Boot firmware, bootloader, kernel, init system, spawn into your shell, spawn your X server loads your window manager, and then you're done. And yeah, that's the talk. So any questions? All right. Well, thanks everyone.